Subscribe now and press the bell icon. Never miss an update.
Good evening children, this is Padma from G.k.Jain schools. Let us continue with the integral calculus from 12th business maths. In today's class, we are going to see the properties of definite integrals. We have 7 different properties. We'll see the properties first and then we'll go ahead with the sums and exercise. Let's move on to the topic now. Let us see the properties now. First property, integral a to b f of x dx is equal to a to b f of t dt. You can see in the do you know, a to b dx is equal to b minus a. That is upper limit minus lower limit. Second property, a to b f of x dx is equal to minus integral a to b to a f of x dx. That is, when the limits are interchanged, the sign will also be changed. If it is plus, it will be minus. Then if f of x and g of x are continuous function in closed interval a comma b, then a to b f of x plus or minus g of x kept in together bracket, no, you can split it and write it as a to b f of x dx plus or minus integral a to b g of x dx. Fourth one, if f of x is a continuous function in closed interval a comma b, there exists a point c, there exists another limit c such that a to b f of x dx can be written as a to c f of x dx plus b to c to b f of x dx. Then fifth property, it is very important property, 0 to a f of x dx can be written as 0 to a f of a minus x dx, that is the upper limit minus x dx. This property will be using in the sums. Okay, now the sixth property, if f of x, two types are there. If f of x is an even function, if we are finding that it is an even function, then minus a to a f of x dx can be written as twice integral 0 to a f of x dx. And suppose f of x is an odd function, then minus a to a f of x dx becomes 0. So first, when you are given f of x and if the limit is plus or minus minus pi to pi, plus or minus pi by 2 to pi by 2, such case you have to check whether it is even function or odd function and apply this. Then the last property, integral a to b f of x dx, which can be written as integral a to b f of a plus b minus x dx. Now first we shall see some example sums and also this exercise 2.9. So first let us see the example sum, example 2.78. So evaluate integral 0 to pi by 2 sin x by sin x plus cos x into dx. Okay, so first we will name this as, let I is equal to integral 0 to pi by 2 sin x divided by sin x plus cos x dx, and we shall name this as 1. We know this property, right? The fifth property, integral 0 to a f of x dx can be written as only when you are having 0 to a, that is the lower limit is 0 and the upper limit is any value. Okay, so 0 to a f of a minus x dx, that is whatever a is here, I can write it as that upper limit minus x dx. So that is what I am going to apply here in the I. Wherever x is there, I will make it as, what is my a here, pi by 2, so pi by 2 minus x. So sin pi by 2 minus x divided by sin pi by 2 minus x plus cos pi by 2 minus x. And what is sine of pi by 2 minus x? Sine 90 minus theta, that is cos theta. So this will become cos x divided by, and this is again cos x and this is again sin x, so cos x plus sin x. Now name this as 2. Now what I am going to do, I am going to add this 1 and 2. So adding 1 and 2, I plus I becomes 2i is equal to 0 to pi by 2. First expression is sin x divided by sin x plus cos x, and second expression is cos x divided by cos x plus sin x. So LCM is common, so I can add them both. So obviously the sin x plus cos x and sin x plus cos x, that is the numerator and denominator will get cancelled. So I will get 2i is equal to integral 0 to pi by 2 dx. When I integrate dx, I will get x within the limit 0 to pi by 2. So the upper limit is pi by 2 minus the lower limit is 0. So it is I is equal to 2i is equal to pi by 2 and I is equal to pi by 4. Okay, now the second, example 2.79, evaluate integral 2 to 5 root x divided by root x plus root of 7 minus x dx. So first we will name this as, let I is equal to integral 2 to 5 root x divided by root x plus root of 7 minus x dx. Let us name it as 1. Again, we know this property, a to b, that's why I told you this property is very important. This property and the next property, that is finding whether it is an even function or odd function and then going ahead. So that property is also important. So a to b f of x dx is equal to a to b f of, this is a plus b minus x, this is a plus b, whatever limits are there. Here it is 0 to a means f of a minus x, and here we will take both the limits together, a to b, seventh property, a to b f of a plus b minus x. So what I am going to do, what is my a here 2, what is my b here 5. So wherever x is there, I will replace it by a plus b minus x, that is 2 plus 5 minus x, and here also x is there, so 2 plus 5 minus x, and here root of 7 minus x. So in the place of x, no, I will make it as 2 plus 5 minus x. So what happens here, next step, root of 7 minus x divided by 2 plus 5 is 7, so 7 minus x, plus here already 5 plus 2 is 7, so 7 and 7 will get cancelled, so minus into minus will become root of x. Okay, so name this as 2. We have 1 and also 2, so add them both. So I plus I will become 2i is equal to integral 2 to 5 root x divided by root x plus root of 7 minus x plus root of 7 minus x divided by root of 7 minus x plus root x. LCM is common, so in the numerator and denominator both are common, so cancelling them I am getting 2i is equal to integral 2 to 5 dx, integral 2 to 5 dx. So when I integrate dx, I'll get it to be x within the limits 2 to 5. So upper limit is 5, lower limit is 2. So 5 minus 2 is 3. So I is equal to 3 by 2. So this is how we have to do. These are all very important 5 mark sums. Now let us move on to the exercise 2.9. The first sum is very easy, you can do it as a homework. Now let us see the second sum. Minus pi by 2 to pi by 2. So I told you, whenever you are having plus or minus limits like this, minus 1 to 1, minus 2 to 2, such cases we have to check out for the sixth property, that is whether it is an odd function or even function. So I am taking f of theta is equal to sine square theta. I am going to check f of minus theta. If I am going to check, I am going to make wherever theta is there, I will make it as minus theta. So what happens? Sine of minus theta the whole square. So sine of minus theta is minus sine theta. Minus sine theta the whole square is sine square theta. So f of minus theta is same as f of theta. When you are going to substitute theta as minus theta, that is when I am going to substitute x as minus x, even then they are not changed. There is no change, means that the function will be a even function. Suppose if it is an even function, we can write by the property integral minus a to a f of x dx. If f of x is an even function, then it can be written as twice integral 0 to a f of x dx. What if it was an odd function? Obviously the whole function will become 0. Okay, so this becomes integral minus pi by 2 sine square theta d theta is equal to twice integral 0 to pi. Now see, the limit has been changed here because of the property, since it was an even function. 0 to pi by 2 sine square theta d theta. Now again, we cannot integrate this sine square theta directly, so we'll use the trigonometric formula. We know that cos 2 theta is equal to 1 minus 2 sine square theta. So I need the value of sine square theta alone, so I'll take this 2 sine square theta to the other side and bring this cos 2 theta to this side. So it is sine square theta is equal to 1 minus cos 2 theta divided by 2. So integral 0 to pi by 2 sine square theta d theta is equal to twice integral 0 to pi by 2 1 minus cos 2 theta by 2. 2 and 2 will get cancelled. So I am having 1 minus cos 2 theta. When I integrate 1, I will get theta, minus when I integrate cos 2 theta, it is sin 2 theta by 2. Now apply the upper limit and lower limit. Upper limit is pi by 2. In the place of theta, it is pi by 2 minus sine. See, it is sine 2 theta. So sine 2 into pi by 2. 2 gets cancelled. So it is sine pi by 2 minus sine 0. Theta, wherever theta is there, I can apply the lower limit as 0. So it is pi by 2 minus, we know that sine pi is also 0 and sine 0 is also 0. So pi by 2 minus 0, 0 minus 0. So the answer is pi by 2. So this is very important 5 mark sum, children. This one. Okay. And now we'll see the fifth sum. Integral 0 to 1 log of 1 by x minus 1 dx. So let me finish off this LCM first. So if I take LCM, this will become log of 1 minus x by x into dx. Now let me name this as, let I is equal to 0 to 1 log of 1 minus x by x dx, which is a 1. So we know this property, 0 to a f of x dx can be written as 0 to a f of a minus x dx. So I is equal to integral 0 to 1 log of, wherever x is there, I'll make it as, what is my upper limit here? 1. So 1 minus x. So here x is there, I'll make it as 1 minus x. Here x is there, I'll make it as 1 minus x. Now take this minus inside, no, 1 minus 1, minus into minus will become plus x. So obviously 1 and 1 will get cancelled. So I'll get my new I to be 0 to 1 log x by 1 minus x dx. Now add this 1 and 2, no. So I and I becomes 2i is equal to integral 0 to 1 log 1 minus x by x plus log x by 1 minus x. In logarithm, we have this property, log a plus log b. Using product rule, I can write it as log ab. So this becomes log 1 minus x by x into x by 1 minus x. So x minus 1 minus x cancel, x and x gets cancelled. So it is 2i is equal to 0 to 1 log 1 dx. We all know log 1. to the base 10 will be 0. So you are getting it to be 2i is equal to 0. So I is equal to 0. Now the sixth sum, integral 0 to 1 x divided by 1 minus x the whole power 3 by 4 dx. Okay children, so let us name this as I is equal to 0 to 1 x divided by 1 minus x the whole power 3 by 4 dx. So seeing no, you will be thinking that it is a very difficult sum. No, you can use the property 0 to f of x dx can be written as 0 to a f of a minus x dx. So what is a here? 1. So wherever x is there, we will make it as 1. So this becomes 1 minus x, and here there was a minus sign outside, so minus into 1 minus x. So when I am taking this minus inside, it becomes 1 minus 1. Obviously this will get cancelled and I will get it to be x power 3 by 4. Now shall I bring this x power 3 by 4, and before that shall I split this 1 minus x as 1 by x power 3 by 4 minus x by x power 3 by 4? Yes, that will be simple for me to integrate. So I am splitting it, and then I am taking this x power 3 by 4 to the numerator, so which becomes x power minus 3 by 4, and also this x power 3 by 4 to the numerator. Already there was an x, so when the base or same powers is to be added, so it is x power 1 minus 3 by 4. Now after doing that, when the base or same powers being added, I can now integrate them separately. So I am taking the dx inside, and what is the integral? X power n plus 1 by n plus 1. So x power minus 3 by 4 plus 1 by minus 3 by 4 plus 1. Here it is x power 1 by 4 plus 1 by 1 by 4 plus 1. So I am having it as x power 1 by 4 by 1 by 4, x power 5 by 4 by 5 by 4. Now I can take the numerator, that is 4 into, what is the upper limit here? 1. So 1 power 1 by 4 is 1, minus 0 is 0, 0 power something is 0, and here it is going to be 5 by 4. When I am going to take to the numerator, it will be 4 by 5 into 1 power 5 by 4, that is 1. So 4 minus 4 by 5, when I take LCM, that becomes 20 minus 4, that is 16 by 5. So this is how you have to do the sum children. This is very important 5 mark sum.